Pre-calculus. We are on the third day of Unit 6, Angles of Elevation and Depression. Okay, so I think you're going to like this lesson. But before we go over it, sometimes you might see these terms, especially in a word problem that says the angle of elevation is, or the angle of depression is. And all that means is an angle of elevation, elevate, it means you're looking up at something. So if you're the observer and your eye is horizontal, right? If you look up at something, that's an angle of elevation. If you are standing there and your eye is parallel with the horizontal, right? And you're looking down at something, that's an angle of depression. So let's take a look at this first example. So a meteorologist, I actually had to ask Mr. Wagner about this problem just so I could understand what a ceilometer is, and he explained it to me. It was really interesting. A meteorologist finds the height of a cloud using an instrument called a ceilometer. A ceilometer consists of a light projector that directs a vertical beam up to a cloud base and a light detector that scans the cloud to detect the beam. So a ceilometer with a base of 300 feet, and apparently that's a standard distance. There's two pieces to this ceilometer. They put one of the parts here and one of the parts here. A ceilometer with a base of 300 feet was employed to find the height of the cloud cover. If the angle of elevation, so this piece is measuring this angle, and this one is shooting up light and checking this distance here. Okay, if the angle of elevation of the light detector is 75 degrees, what's the height of the cloud cover? So really, with the information from both of these clouds, all we need is SOHCAHTOA. This side is opposite from the 75 degrees, and this side is adjacent, which is the tangent. So the tangent of 75 degrees, and make sure your calculator's in degree mode, equals opposite over adjacent. And then that would be 300 times the tangent of 75. And I usually put the 300 in front of the tangent of 75, because if you put it afterwards and you forget to close the parentheses in the calculator, you made a mistake. So we got to go to our calculator, make sure our mode is in degrees. Currently, the default is radians, so I'm going to have to change mine to degrees. All right, now that it's in degrees, I can go back and I can do 300 times, what was it, the tangent of, where am I? 75 degrees. Oh my gosh. Okay. Enter. All right, so unfortunately, we're going to have to round this number. So we're getting 1,119. I'm going to put 0.62 feet. And sometimes we have to round. And that's what they're asking for. They're asking for that height. So x is approximately 1,119.62 feet. And that's it. SOHCAHTOA. Next problem. This problem is also SOHCAHTOA, but you have to use it twice. So at the top of the Board of Trade building in Chicago is a statue of Ceres. Did I pronounce that right? I hope I did. The Roman goddess of wheat. From street level, 2 observations are taken 400 feet from the building. Okay, so the observations are taken from this location. One of them, let's see, the angle of elevation to the base of the statue, here's the base of the statue, right, is found to be 55.1 degrees, while the angle of elevation to the top of the statue is 56.5 degrees. What's the height of the statue? Well, we are going to, using SOHCAHTOA, we're going to find the heights for x and y separately in 2 different proportions, and then we're just going to subtract them. So we'll start with our 55.1. So the tangent of 55.1 degrees equals opposite over adjacent. So that's going to be 400 times the tangent of 55.1 degrees. And I'll put a little degrees on there. And that equals x, and that is approximately 573.39 feet. Now, we got to get the other one. So let's find y. So the tangent of 56.5 degrees equals opposite over adjacent. So that will be 400 times the tangent of 56.5 degrees. And that will give us y, which is going to be approximately 604.33 feet. All right, what's the difference? Y minus x. And that's going to be approximately 30.95 feet. Just subtract the two. Moving on. Example 3. A security camera in a neighborhood bank is mounted to a wall 9 feet above the floor. So this is an absolutely amazing likeness of a security camera. Thank you very much. I appreciate that. What angle of depression, so we're looking down, should be used if the camera is to be directed to a spot 6 feet above the floor, okay, and 12 feet from the wall. So I kind of just did a quick little shot here, drew a visual for myself so I could figure out what I'm doing here. I've got to find the measure of this angle. So the tangent of this angle, which is x degrees, equals opposite over adjacent. Well, in order to find the measure of an angle, we have to do inverse trig. Remember, inverse trig. So these would end up canceling. So x should be whatever the inverse tangent of 3 divided by 12 is. And on the calculator, if you do the second inverse, and you can simplify 3 divided by 12, or you cannot simplify it, the calculator will do it either way, it will give you the measure of the angle. And I'm going to write x is approximately, since we had to round, 14.04 degrees. So anytime you're trying to find the measure of an angle, you are using inverse trig. All right, we're moving on to the area of a triangle. If my computer will let me. Okay, so you guys know the formula for area of a triangle is 1/2 the base times the height. These formulas they're mean exactly the same thing. Okay, so look at this formula here. This is just, for example, 1/2 a times b times the sine of c. And I just just remember that the capital angles are across from the lowercase sides, the same letter. But think about what this means. 1/2 a times b times the sine of the angle that's in between. Well, what is the sine of the angle that's in between? In a right triangle, it's opposite, which is the height, over the hypotenuse, which is a. Well, so if I rewrite the sine of c as hypotenuse over a, you're going to see those a's are going to cancel. So there's our formula for area of a triangle, 1/2 base times the height. So anyway, that's where the formulas come from. And you don't really have, this looks complicated because the a's, b's, and c's are all switched. But I don't even think about that when I do these problems. We need a SAS, side angle, side triangle. If you've got the two sides and the angle in, oops, let's try that again. The angle in between, I usually just write area equals 1/2 6 times 8 times the sine of the angle in between. And of course, that's in degrees. So you break out your calculator, and I mean, you don't really even need a calculator because I usually do 6 times 8 is 48. Then I do half of that. Sine of 30 is also 1/2. So that's going to be 12 units squared. And don't write 12 squared. A lot of people, I see this. That is something different. That is 144. All right. So if you don't get a SAS triangle, you've got to get a SAS triangle first before you can do the problem. So for this one here, the first thing I need to do is find a missing side. So I'm going to use what we have learned earlier in this chapter, the law of sines, so that I can go ahead and find the measure, there we go, of this side. So 5 is to the sine of 130, and that's 130 degrees because 130 plus 35 plus 15 adds up to 180. So there's my pair. 5 is to the sine of 130, as x is to the sine of 15 degrees. Cross multiply, divide, you get x is approximately 1.69. Now, unfortunately, we're going to have to use a rounded calculation and another calculation. It's just the way it is. Sometimes we have to do it. If you do, just use as many decimals as you possibly can in your calculator. So using the formula, let me pause for a second. Okay, so now that we have x is 1.69 and we have this side has always been 5 and the angle in between is 35, I've got a SAS triangle. So now I can do 1/2 5 times 1.69 times the sine of 35 degrees. So you break out your calculator and you get 2.42 units squared. And it's area, so it's units squared. And I think that is all. Peace out.